Next, I would like to request Mr. Vivek Gupta, General Manager, DCM Shriram, from 2006, for all the 8 plants at Kota, power plant fertilizers, cement, caustic soda, carbide, PVC, Fenesta, building systems, and Shriram Excel. His rich experience includes control and instrumentation of power plants, design and engineering for more than 30 years. I would request him to come on the stage.
Good afternoon, brothers and sisters. First of all, I would like to convey my sincere thanks to ARC for giving us an opportunity to present a paper on upgradation of DCS in fertilizer urea plant. From the last 2 days, we heard a lot about data. I have not come here with a long data, but whatever data we have to analyze and ultimately improve the performance of the plant to achieve the final goals, we have to come to the fact that the Indian industry is now more than 50 years old. And the plant in which we have done the upgradation is in its 46th year of its existence. It is one of the oldest fertilizer plant of India. Started production in 1969. So we were just hearing about a lot of new things coming in the field of control, instrumentation, and automation. This plant, when started, was only having the pneumatic systems. Nothing, no digital signal, no 4-20 signal, no HART, no Profibus, no field bus. Nothing was there. It was only a pneumatic signal. And you believe me, still after the upgradation, we have not removed those old instrument air lines, which are intact as of time also. As of time, you can come and see in the plant those copper tubings, which are there from field to the control room. Some of them are still existing. Now, let me start. See, the fertilizer plant has got 2 different parts. One is ammonia and another is urea. And you have to have a designer for that. That is the condition for any of the plants. So ammonia, we have Holder Topsoe, and for urea, we have STEMI Carbon. And Chiyoda Corporation, Japan, was the engineering who have done it. Now, as I already told you, 67 actually it started, and 69 we started the production. And those who are aware of the fertilizer industry, we have a hydrolyzer section also. So year 2000, we installed a small DCS in that particular portion. And majority of the field transmitters and control room instruments were pneumatic. Now, what were the limitations? Let me be very frank with you. Other than the field instrumentation, because we were not having the spare parts for them, otherwise we didn't have any problem. Local controllers were there in the field. The only thing was that the diagnostic features, which we talk of as of time. And the most important problem nowadays is the new instrumentation engineers, because now instrumentation is not an instrumentation branch, it is more towards IT. That is what we are listening from yesterday, from first session till today. So new engineers, they all want the white collar jobs. They don't want to go in the field to attend those things. So those were the kinds of things which were existing before 2013. And of course, the problems which you could read on the slides are the natural problem, whether it is pneumatic, or maybe the electronics, or maybe the microprocessor base, or the instruments which are coming as of time. So in the year 2013, when DCM Shriram thought of upgrading it, because of the limitations which you have just now seen. Now, whenever you upgrade the system, it is not only the instrumentation team which faces the problem. As yesterday, that NTPC madam, she was telling about the manpower. The same condition is existing here also now. In 2017-18, majority of the people will get retired in our company also. So maybe 700 to 800 years of man experience will go. And then the plant operations, how they are going to happen. because to run a fertilizer plant is not an easy thing. You have to have the deeper knowledge because you have to deal with ammonia, and it is very dangerous. So what was done was a cross-functional team was made, first of all, to understand it, and which consisted of process, instrumentation, and electrical engineers. And then what we did is, the documentation part nowadays, you have all soft copies available with you. But those were the days when it was only made on the tracing sheets, and you have to rub with blade if you have to make any changes. Those sheets are of course available as of time also as soft copy now after taking the photographs. So all those drawing sheets were taken out, which were there as commissioned to see what was the actual project status as of time. Second thing, the installation of hardware and DCS panel, they were studied. Because during those days, I will show you a photograph. During those days, the size of the control room used to be very big. I can say almost 75% of this room is the size of the control room. Now, it will be only 25% maximum. So those days, the number of panels used to be also large. I was just discussing with Mr. Sani during the lunchtime. We are the only user in India of 2x30 processor of Rockwell. It was in 1987 when they supplied it to us. So this company, DCM Shriram, has got almost 16 different kinds of PLC and DCS, which are existing in one common facility at Kota in Rajasthan. Third thing was, then how to do that migration. The challenges were two. When this project report was prepared and was put to the management, as all of us are aware that urea is a government-controlled commodity. You cannot produce even a single kg of urea other than what has been allotted to you by Government of India. And if you are stopping your plant, you have to inform well in advance that so much of urea production is going to be shortened by you during this financial year. So the straight way, our managing director told, you can go for the upgrade, but no plant shutdown will be allowed. You have to do it in the running plant. So that was the major challenge why this paper is presented today. Otherwise, to take a shutdown, to replace the things, make the plant again healthy, it is always possible. You have to do a meticulous planning, that's all. Now I will show you how we did it. A very detailed project schedule was made, although you may not be visible line by line. But from the day one, when the indenting was done, till the last date, when we will be handing it over. Now here the schedule was quite large, because we were not stopping the plant even for a single minute. The urea production was all the time over there. Now what we did, as I told you, we take out all P and IDs diagrams, all drawings, all safety interlock schemes, because those were the relay-based interlock schemes. It is not of nowadays. You can still take a picture, take a graphics out of your monitor, and then you can accordingly change it. Then we had to prepare the specification for the new instrumentation. Then the cable routing. See, if you are making a new plant, you can always have access. Wherever you want, you can route the cables. Wherever you want to put junction boxes, you can always put. But when you are going for the upgrade, you have to see the actual condition of the site and how to implement those. Then we had to prepare a detailed IO list and the assignments thereof. And then what we did is, we actually interviewed the plant operators. See, there are things when the plant is being operated from the big control desk, they have got a habit of operating the same time. They will go to that desk, 3 people will stand, one will push one button, another, somebody will see that those pneumatic recorders. They have got that habit of running a plant. So they have got in their mind, how do they coordinate to run a plant? So what we did is, we interviewed the people from the urea process side, and we even interviewed those people who were actually posted in the field for a small sections. just to have a feeling that what kind of things do they think they should have whenever we go for the upgrade. So that was the important part which we did. Then we made a control equipment group layout because we had to accommodate the new control panels as well as operator consoles, keeping the older one simultaneously. Please note, because the plant was in the running condition. It was not like that I have an empty space where I can put panels. And then UPS was already there, but since it was a pneumatic, very small UPS power was already existing with us. Now what we did, this is the detailed IO list, what we prepared along with the existing instrumentation. And then we took out the control room layout, what was existing, because ammonia and urea, we have a common control room. Those who are aware of fertilizer industry, it exists side by side. Now see, the older days control room used to look like this. You used to have a lot of recorders, indicators, hardware annunciators, big control desks. Now the picture which you are seeing at the behind is the older ammonia plant, and the left hand side is the urea plant where I have marked it with a red square. We have already upgraded ammonia plant in 2006, and you are seeing that the operator console is there, the people are sitting. And the box one is still the older one. That control desk which has got the monitor installed on that. It is not like that we have an open desk where you can keep your monitor. Now, the panels which you are seeing existing is the ammonia. Now, we had a space left out for installation of the new DCS panels because we didn't have anything more than that, and we had to accommodate there itself, seeing the control room. What we did is, we had a very in-depth study of the overall plant, and then we prepared the cable tray layout, because that is very, very vital. You see, instrumentation signal cables cannot run in parallel with the high voltage electrical cables because of the interference. So that, keeping that in mind, we have to prepare a cable tray layout very meticulously so that we don't have any kind of interference. Then we have to prepare the electronic grounding scheme because the new system was there, and this time we went for a chemical grounding, right? Then what we did is, after indenting the DCS, now here we had a hydrolyzer section. I am not taking the name of the vendor, but the X vendor has already got a DCS in urea plant. In ammonia plant, we had a DCS from Y vendor. Now the question came whether to go with the X vendor who is already working for the hydrolyzer section of urea plant, or to go with the Y vendor who is already working in ammonia plant. Now see the condition, because the urea plant operators were acquainted for that small portion of that hydrolyzer. Now how to go about that? We had a very detailed discussions with both the vendors. And then ultimately what we did, it was a very, I say, important kind of decision that we took out the X vendor system out. And we went for the newer system, which was of Y, which was already existing in ammonia plant. And what happened is, we had already decided that in case we have to run the plant with the upgradation and replacement in the running condition, the FET has to have very, very stringent condition. Because after you install it and start the plant, it should not happen that something fails. So very hard FAT was done at this site. Normally what happens is, in the newer plants, you get a lot of time to do the FAT. You do comfortably. But here, the time was not a constant. The constant was the accuracy with which the system was designed. And what was happening is, actually the people were operating from the control desk. So they have got a habit. This is this section of the plant, this is this section of the plant, this is this section of the plant. these two people are expert in this, these two people are expert in this. Now when we made a graphic, now see, the older people, we want the graphic as of old control desk, because we are not much familiar with this DCS kind of thing, the graphic which you make. Now what we had to do is, it's really a funny thing, but we had to do it. For all the important graphics, which nowadays the DCS has, we have to make a graphic looking like a control desk. We have to show a blocks, is okay, this is this indicator, this is this indicator, this is this control valve's controller. I will just show you a picture also of this. Sorry. So we had some space in the control room for operator consoles. We had some space in the control equipment room where we had to install those new panels. And the number of input outputs which you are able to see on my slide, those were changed. Now, the first thing was to change the hydrolyzer section. What we did is, we started at exercise at 9 o'clock in the morning after the tea was finished. From 9 o'clock, almost around 8 hours we took. We did not allow anybody, even from process, from instrument, from electrical, to go out for anything else. We arranged everything else inside the control room. And the hydrolyzer section was successfully changed from the old DCS to the new DCS. Mind it that the operator console was still the older one. We had temporarily installed a new operator console for the new DCS. And then the rest of the exercise was since pneumatic. So we had to do it very, very meticulously. What we did is, we posted people. Now suppose one closed loop was being changed. What we did is, we posted one person at the site. All wiring was already done for the transmitters, for the electronic transmitters. Even cable lugging, tagging, everything was done. Just change the wire, and we took the control valves on the hand jack, immediately changed it, and the fine tuning was done at that same moment. This is how it was done. See, this is a graphic of something looking like an old control desk. Lot of blocks are made. These blocks are something like a control desk having got the indicators, the recorders, or the local controllers, and have the feeling of the newer one. Now this was the newer one graphic of the previous slide. So we had to make such kind of graphics. Why I'm telling you is, see, the both kind of manpower is there. The newer generation who are operating the plant are more comfortable with this kind. Of course, we had to give them a training. They were there at the FAT time also. And the previous slide which I had shown you was having a slide which was showing the control desk feeling. Now slowly the previous slide has gone. Now they are not opening that particular graphic. They are working with this kind of graphic only. Now this is a kind of an DCS architecture which we had actually made. And what we did is, we give one independent operator console to the shift in charge. Shift in charge is an old person having experience of more than 30 years in the plant. So he knows both the things. And the newer generation were giving the dual monitors so that they can operate from there. I will show you a picture of that also. See, the young guys who are sitting in front of the monitors are with the newer system. And behind, the old pneumatic system control panels are still existing. So this is the latest picture. And behind these two gentlemen is the new DCS panel. I have merged both the photographs. Now still the older one is existing. Of course, they are no more in line. This is no more in line. Everything is now on the operator console. Now these people are so happy, even the older generation are so happy with this new one that now they are not looking towards the old graphics. So why I have presented this is that while we are going for the newer automation system, big databases, analysis of that, running a plant more efficiently, see, it is a very, very energy intensive plant. Fertilizer plants are very, very energy intensive. Nowadays, the newer plants are almost with 6 gigacalorie per metric ton of urea. In those days, like plants of ours, we are with 7. So you can think of 2 gigacalorie per metric ton of urea. That is the difference. That the differences are not only of the process, the differences are like if you are operating with the coal-based power plant or you are operating with the gas-based. The pressures were high during older days. Now the pressure levels are within 200 kg, even in ammonia plant. We have 325 kg. So there are so many reasons for those. And I tell you that the Fertilizer Association of India, FAI, they have done a study that what is the forced shutdown due to the failure of instrumentation. And it has come up that in ammonia plant, it's nearly 10.5%. And in urea, it is almost 6%. Because those who are aware of fertilizer industry, it takes almost 36 to 42 hours to start a fertilizer plant if it trips once. So this is the kind of the problem which a fertilizer plant has to face. It's not like that they cannot upgrade. We have field bus also in our ammonia plant. And here also in urea, we have taken almost all the new things. All heart-based instruments are there. We have got all the diagnostic facility available with us. But the only thing is that the 2 things has to be ensured. First is the manpower which is working and running the plant. And second thing is about the obsolescence, which is there with everybody else. Now we have taken Windows 7. God knows what Windows is going to come after 3 years, 4 years. And the answer from the DCS vendors is very simple. Sir, please change it. Please replace it. We cannot support you. They will say, okay, we support you for 10 years, 15 years, but we cannot guarantee you about the operating systems. If XP is changed to Windows 7 or Windows 8 or Windows 9, we cannot help you out. Now, it's not a simple replacement of only the monitors and PCs. You have to change the DCS because the newer generation of DCS versions are not compatible with the older ones. So you have to replace it. So that is the main challenge. And that I think my other friends who are from the end user side, they are also facing the similar kind of problem. Because instrumentation cost is roughly 3 to 4%. But it is the most important one in any plant. They are the last one to enter, and the fastest results are expected from them. If any shutdown is taken, they are the last ones to be given the job, because when the main equipment will be taken out, then only you will be allowed to take out the instruments. And when the equipment will be again installed, you will be the first one to install it back. So always urgency, urgency, and urgency. And all kind of information should be always available. They are the first one to be given that information in the control room, whether you are ready or not. We are not able to start the plant because you are not given us the temperatures. Please do it fast. So this is the kind of challenge which I think the instrumentation guys, they have got a Herculean task of putting the system back. Now, after doing the benefits, what we have realized is not a newer one. This is all what we have. Because when you prepare a note for the management approval, the ROI is always the first thing which comes. And if you shift from any system to any system, the ROI, you cannot bring it in crores of rupees or something like that. Because all these figures cannot be changed. But one thing is taken sure, that the deviations to the set point, which a pneumatic system has got, you can certainly reduce that band. Once that band is reduced, it means the less jerk to the main equipment. And certainly their life gets extended. Thank you very much. I'm well within the time.